on to our last speaker of this session, and they've travelled the furthest of all, and they've come from Australia, and it's Sasha Lanyon, and going to speak about heat treatment of serum from calves, PI calves with BVD to remove interference of colostrum-derived specific antibodies on the antigen detection by ELISA.
Thank you. Good morning. I'm conscious that I'm standing between you all and morning tea, so I'm going to pretty much skip straight to the point and skip through the BVD introduction because I think we've all been brought up to date on that very well. But I'd just like to thank Julia for putting this out for me earlier and reiterate that persistently infected cattle that maintain BVD in our cattle populations can be clinically healthy, and we can't always pick them out of the herd, and so we do rely very heavily on our diagnostic tests to identify them. Our diagnostic tests are generally pretty good, and I'm going to really focus on a very specific problem that is still present in our diagnostic tests, and that's the interference of colostrum-derived antibodies with the detection of the ERNS antigen in ELISA in the serum of very young PI calves. So we have a PI calf born, dropping out, there we go. Have a PI calf born, and more often than not, that calf is born to a dam that has undergone her own acute infection early in that pregnancy, and as a result, she has very, very high levels of specific antibodies. She passes those antibodies to the calf in the colostrum, and then, of course, those antibodies are present in that calf for some time after birth. Now, when we're trying to detect these PI calves in the first few weeks of life, we can have some trouble detecting that antigen in the serum due to those antibodies interfering with our tests. And this is really one of the reasons that ear notches have seen such a rise in popularity, because the ear notches are reported to not be subject to the same interference. However, there's still some contention over that, and certainly our experience has been that even the ear notches suffer a significant drop in the antigen signal within those first few weeks of life. And we in our lab have certainly had some borderline and some false negative results in those very young PI calves with ear notches. And we heard about the Swiss situation earlier where there are some false negative animals that have then later on come to surface and cause a problem. So we were looking at whether there's a way we can actually remove the antibodies from that sample and prevent that interference being a problem at all. But before we could do that, we really had to look at what that interference looks like. And so what you'll see here is that we took some PI serum from an adult PI cow, and when we test that PI serum in our antigen ELISA here, it gives us a very strong result up around that 3.4 result, and that's exactly what we'd expect from an adult PI individual. If we look just at a sample here that contained no PI serum, as you'd expect, we got a negative result, and that's beautiful. But what happened is we diluted that PI serum out, and the blue line here is what happens if we dilute that PI serum out in a diluent that does not contain any specific antibodies. And you can see that we get all the way out here to a sample that only actually contains 1.6%, so less than 2% PI serum, before we actually reach a negative result on that ELISA. And so even here, when we've only got 3% PI serum, that's still enough to give us a positive reading. So they really are very, very strong and really distinct. On the other hand, in the red line here, when we dilute that same PI serum sample out in a diluent that contains specific antibodies, so our diluent that we used here was actually a pooled serum sample from seropositive cows that had been exposed to the exact same strain of BVD, so it was a homologous specific antibody. And you can see that that line drops a whole lot faster. And in a sample here that's still 75% PI serum, so 3/4 of that sample is still PI serum with those huge levels of antigen in it, we're already hitting a negative result. So we have a really dramatic drop in the signal and the antigen we can detect as soon as there are specific antibodies in that sample. And so, point those out. When we look at what's happening in the antibody in those same samples, this is corresponding with that red line there. These are our antibody levels. And it's around this point here that this is really the sort of situation that we see in our PI calves, where we've got a sample that we know contains enough antigen to give us a very, very strong reading. But due to the high levels of antibody in that sample, giving us quite a strong reading on the antibody ELISA there, and certainly consistent with what we've seen in field samples from young PI calves following colostrum ingestion. That causes that reduction, very strong reduction there in the antigen that we're able to detect. So we used this mixture here, which was 50% serum from our PI cow and 50% serum from our seropositive animals as our experimental sample going forward. And we put some controls in there. We used positive control was our PI serum diluted to the same 50%, but diluted in diluent that didn't contain any antibodies. And our negative control was just our antibody positive, our seropositive cows there. And so we subjected these to a couple of methods that we adapted from a paper by Moore and Copeman in '91, and that paper was addressing a very similar problem in parasitology. And so when we had our untreated samples, as we've just seen from the previous figure, we had a very strong response in our positive control here in the red bar, and a negative response here on the blue bar, which is our experimental sample. And the first treatment we tried with these was boiling the sample, so we subject it to a boiling water bath for 7 minutes, and then we centrifuge the sample, the precipitate that's formed during the boiling is then centrifuged out, and we can test the supernatant in the same ELISA. And that boiling procedure allowed us to recover about 20% of the signal that we lost here. So this black bar here is our signal recovery. You can see we recovered about 20% of the signal we'd lost. But it did have quite a dramatic effect on the positive control as well, and we actually lost signal from the positive control. So we weren't quite there yet. But the next method we tried, we got pretty excited because it actually worked, which was fantastic. So we actually managed to recover more than 90% of the signal that we'd lost following colostrum ingestion by first treating the sample with an equal volume EDTA added to the sample, and then going through that same procedure of subjecting it to a boiling water bath, centrifuging out the precipitate that was formed, and testing the supernatant through the ELISA. And you can see there that our experimental sample in the blue bars is now giving us a very similar reading to our positive controls, and they're right up there around the same as what we get in our untreated samples from our adult PI. So that was really pretty exciting for us. We thought, we've got something here that actually works quite well, but of course the ultimate test is to put it onto field samples and see if it still works. So we had some PI calves and some non-PI calves here. I will just point out that we only had small numbers here, and this was part of a larger trial we were running at the time. I'll point out that our non-PI calves that we had in this trial were actually seropositive. They were congenitally infected after that PI window, so they were still exposed to BVD, but they were seropositive at birth. They weren't true naive calves. But we tested these guys every 2 days for the first 2 weeks of life, and then weekly until 5 weeks of age. And you'll see in the dotted lines here, before colostrum ingestion, these are our PI calves. Before colostrum ingestion, we had those really strong positive results, as we'd expect. And then after colostrum ingestion, those antigen results really plummet quite dramatically. And they stayed negative for anywhere between 8 days and up to the 4-week mark in one of our calves there. When we then took those same serum samples and we treated them using this procedure, we managed to, again, recover that signal, and you can see that all our calves tested very comfortably positive. The lowest we got was about a 1.9 for that entire period in the early postnatal life. The yellow line down the bottom here, these are our non-PI calves, and you can see that they're pretty consistently negative. The only time we had any dramas with specificity was on the day of birth, when we had 3 of our non-PI calves that did give us very low readings once we'd treated those samples. But like I've already mentioned, they were animals that had been exposed, so whether we're picking up some residual virus there, we're not sure. But we were pretty stoked to see that this was working really clearly, and we got a very distinct separation there. So we believe that this is working with the EDTA being very important to break open those antigen-antibody complexes that are present in the serum. And then when we boil the samples, you can see a white precipitate forms, and we believe that the antibodies are being denatured and precipitated out. We centrifuge them down, but the ERNS antigen BVD antigen seems to be very, very resilient. We can't seem to kill it. And so it remains unaffected in that supernatant that we can then test in the ELISA and detect it quite comfortably. So we've got a lot more work to do on this, and if anyone has access to regular samples that they'd like to let me test, that would be great, because we'd love to get a bit of a database behind this and really see how robust it is, and see there might be a need for some slight adjustment of the positivity threshold we're using to ensure that specificity. But we believe that this is a really handy tool that could come in handy in lots of places, particularly because it does have the option, it could be adapted for high throughput testing in a 96-well format quite easily. It's very inexpensive, it's rapid, it only adds about half an hour to the testing procedure for the ELISA, and the most specialised equipment it requires is a centrifuge, and so it could really be done in any standard diagnostic lab quite comfortably. Just a few acknowledgements. IDEX provided all the ELISA kits for this study. MLA, our Meat and Livestock Australia, funded the larger study that this stemmed from, and Gribbles did all our PCR to confirm the PI status of our PI calves and the original PI that we got that serum from. And then these are all the many, many people that were involved in that larger trial. We wouldn't have had PI calves on the ground that we could test this on if it weren't for them. So big thanks to everyone that was involved. So that's all from me. Any questions?
Thank you very much, Sasha. That was a very practical talk for us, to our people that are based in labs especially. Anybody any questions for Sasha? I get to ask another question. Sasha, I was just wondering, a lot of us that are lab-based like the reassurance of moving to PCR when we need it. Have you tested how the performance of PCR and possibly sequencing is affected by this treatment?
Yes, so the treatment will denature the RNA, the BVD RNA there, so we can't then treat those same samples on PCR, but it's quite easy to treat just a small aliquot of the sample.
Split.
Lovely. Thank you.
Okay, thanks very much, Sasha.